The I can statement is actually worth looking at this way, this time. It says I can use roots in a polynomial equation to find other roots. How could I use roots, which by the way is another way of saying what? X-intercepts or zeros to find other x-intercepts or zeros. Nobody knows, huh? Synthetic division. I can use synthetic division. I'm going to use synthetic division like a cell. To reduce. We talk about that, reduce. If I have something that's x to the fourth, how many zeros would I need to factor out of it to become x squared? 2. If I had x to the sixth, how many zeros do I need to factor out of it to become x squared? 4. Why am I talking about reducing x squared? I can factor it or quadratic polynomial. Use synthetic division to reduce to x squared, which is your quadratic. For your favorite F word, if possible. Usually at this point in time, it's not. To factor or use QF. QF is shorthand for quadratic formula. We're going to do everything today and tomorrow 100% old school. No technology whatsoever. It's not going to be a lot of fun. But you'll remember it.
Bless you.
Start off with what's called rational root theorem. For some polynomial it's written really funny the way most textbooks have this. Qx to the n, it's dot, 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 some number at the end, p. That's what it is. P is just a constant. There's a whole bunch of stuff in the middle, okay? Below the dot you build. Whole bunch of stuff in the middle. I'm focused on the front and the back. The list of potential. What's potential mean? Yeah, all possible. Maybes. List of potential rational zeros. Rational, think ratio. Just means a fraction. Fractions can be a lot of things. Is 4 a fraction?
Yeah.
Yeah, why? 4 over 1 is 4 over 1. Everything can be a fraction. The list of rational zeros is found by factors of p over factors of q. I'm pretty sure this is where the old saying mind your p's and q's comes from. Or it might come from an English class. Probably an English class. But it makes sense here too. You guys are too young to have ever heard that, aren't you? You heard it? When I teach this, I won't actually talk about P and Q. Read the back. That's the back. Over the front. Is where's Q? In front. I'm not saying that the next 2 slides will be any fun, because they're not. It's kind of boring, but it's also really kind of easy. It really is. We're going to skip that one, jump to this. List all the possible rational solutions for the given equation. So we think about the factors of the back. What number is in the back? 45, ignore the sign. Okay, just 45. What are factors of 45? 9 and 5. I'm gonna include the plus or minus symbols, plus or minus 5, plus or minus 9. Got another pair? 15 and 3. I'm writing these out in increasing order, by the way. It's way too redundant. What's the last pair? 45 and 1. That's the factors in the back. That's going to be sitting pretty over the factors in the front. What number you see up front? 7. 7's prime. What are its only factors? 1 and 7. Minus 1 plus or minus 7. Yeah, here's the boring part. Write the whole list. First off, you take everything you have and you divide it by what? 1. It's this sitting over this or this. If you divide everything you have by 1, you get the same thing back. If you divide everything by 1, what should you do? You divide it by 7. You don't be pushing buttons in the calculator. 1 over 7 is 1 7. 3 over 7 is 3 7. There's your full list of potential rational answers. Does that include the imaginaries? No. Does it include funny things like square roots, you think? Anybody know what you call like square root of 3? You don't call it rational. What do you call it? Square root of 3, you call it cubic? Irrational. That's right. This is only for rationals, not the irrationals. So this doesn't help you find any truly funny zeros. Just ones that kind of make sense. All right. Here's the next concept, the fundamental theorem of algebra. Fundamental theorem of algebra basically says that x to the n has exactly n solutions, real or complex. Real or complex. I've got a question like this on your test Friday. I guarantee you it'll be missed by 1/5 of the student body. It's easier than a lot of here. It's way easier than a lot of here. Low and 5 kids will miss it. To figure out what x to the n is, you need to figure out what the first term is. I talk here about power function. Power function is literally x to the n. It's the first leading piece. So you've got an equation up here. This is way harder than what's going to be on your test. Figure out how many solutions she has by thinking about what power functions are. But how many solutions x minus 3 to the 4th times x squared plus 4 cubed has? No. That's 4 plus 3. Doesn't have 7. No. How are you coming up with this thing? Are you just pulling these times 3 plus 4? There you go. Based on multiplicity, this guy has how many zeros? Based on multiplicity, x equals 3, it happens 4 times. Another way of thinking about this is we would write x minus 3 4 times and it would create x to the 4th. X times x times x times x. This guy has a multiplicity of 3, but how many zeros are there? There's 2 zeros, it does the square. 2 zeros, each with a multiplicity of 3 is 6. So 6 zeros happen. Or we think about writing the x squared part 3 times, and x squared times x squared times x squared is x to the 6th. 4 plus 6 is 10. And that is the number of solutions. The thing has 10 solutions. Are they all real? No. How many of them aren't real? X squared plus 4. Are there real answers there? Use that little blank piece of paper in your head, set it equal to 0. X squared plus 4. Are there real answers there? No. How many times do they happen? 3 times. There's a plus or minus twice side. They both happen 3 times. 6 of those solutions are not equal. Or sorry, are not real. These are the only real guys right there. All right, so you ready to move on? We are. What are all the complex roots of the polynomial equation? Word complex was mentioned. What do you think that means? Real and what? Imaginary. Real and imaginary. Now we're going to do this entirely old school. We're going to create a list of potential things we can throw at it. I need a list of things I can throw at this thing with synthetic division that we talked about. So I need a list of factors or a list of zeros. Factors of which number first? 2. What are the factors of 2? 2 and 1, plus or minus 1, plus or minus 2. And that's sitting pretty over factors of front, 1 and 3. If you take 1 and 2 and you divide them by 1, you get them back, don't you? Plus or minus 1, plus or minus 2. You divide them by 3. I hope that you realize that you get 1/3 and 2/3 back. These are 8 potential answers. Now that guy is x to the 4th. How many answers will it actually have? 4. How many answers do I need to pull from? Go back and read the first thing we talked about. We used synthetic division to reduce to a what? X squared. So I can do something I know how to do. How many answers do I need to pull from? 2. This is basically guess and check. Guess and check. Pick one. Pick a number. 2. The x value goes out front. Coefficients up top. If you actually do this, you'll remember this the rest of your life. You sit there, it'll just be one more thing you'll see again next year. You'll be right back in my class. Algebra 2 is a Tennessee graduation requirement class. You must pass Algebra 2. And so long as you're in Dresden High School, you must get through Navy. You need to realize that. You want to blame me for you not getting a diploma later in life? That's cool. It ain't me. We drop. Twice the 3 is 6. Then we add. We get 10. We multiply and we get 20, then 22, then 44, then 43, then 86, then 84. Yay or nay? Why nay? Because it wasn't a 0. So, I'll throw away the positive 2, and we'll try something else. It's up to y'all. I know what the answers are, but I'm cool. I can do this all day long. Pick one. We've got 7 choices left to make. You had to hear something. 3's not even in the list, buddy. Yeah, at least you give me something to laugh at every day. 1/3. What's 1/3 of 3? 1. 4 plus 1. 5. 1/3 of 5.
No.
What's 1/3 of 5? 35 is 15? 5/3. 1 times 5 is 5. What's it sitting over? 3. About 2 plus 5/3. That's right, 11/3, because 2 is 6/3. 1/3 of 11/3. third of 11/3 is not 11/3. 11/9. Multiply denominators together, multiply numerators together, 11/9. I don't think this is going anywhere, but since y'all need practice fractions, -1 plus 11/9. Not negative, it's 2 9s. Because -1 is 9/9. -9 plus 11 is 2. 1/3 of 2 9s. 1 times 2 is 2. 3 times 9 is 17. Is it going to be 0? No, not even close. You might know what it's going to be.
Slash asked me.
27 times 2 is 54, right? 52 over 27. Okay, so you guessed positive 1/3, and it was no longer a choice. You got 6 more guesses, unless you guess the next 2 right. If you're just sitting there not writing anything down, this is why you won't remember it. You'll remember this because of the struggle. By the way, don't share your homework with anybody. Make them struggle or lose their points. Don't share it. I need another guess. I got 6 more choices. -1. Drop. That's a 3. We multiply. That's a -3. We add. That's a 1. We multiply. That's a -1. We add. That's a 1. We multiply. That's a -1. We add. That's a -2. We multiply. That's a 2. And we get a 0. Cool. You have successfully basically pulled an x out. You've gone from x to the 4th down to x cubed. You need 1 more. Now, also we're talking about, if you go back in and plug in up here, you're reducing x to the 4th to x cubed. This is what you want to work with, because this is 3x cubed plus 2x plus x minus 2. You want to pull another x out of it so that it becomes x squared. So you're not working with the original equation from here on out. You're working with the smaller set. The goal is reduce to x to the 2nd. From here on out, all our guesses go into that synthetic division with different coefficients. Anyways, make another guess. Have we done 2/3? We haven't done 2/3 yet, have we? What's 2/3 of 3? 2. 1 plus 2 is 3. 2/3 of 3. 2. 1 plus 2 is 3. 2/3 of 3. Look at that. You found it. All right. What is that as an expression of x?
3x plus 3x. 3x plus 3 squared. Oh my God. Plus 3 plus 3.
There we go. All right. You don't have to do the next step, but you could. Is everything divisible by 3? It is. That'll reduce it. What's the benefits of reducing it? There's 2. For one, you know immediately if it factors or not. Will it factor? There's a 1 at the end. Are the factors of 1 that add to the 1 in the middle? No. Not real numbers. So we won't factor, you get to use a QF. And the advantage here is that you're not using 3 for A, B, and C. What are you using instead? 1s. You're using smaller numbers. That's the big advantage of reducing. I think we've already written quadratic formula once today. So x is going to be -b if b is 1, -1, plus or minus square root of a 1 that's squared. Minus 4 times 1 times 1, sitting pretty over twice 1. Let somebody else know. Well, I'm glad you know what you're doing, you just dominating the class. Really isn't supposed to call on people. Nobody likes to be called on. Cam, what's the net radical? No, not -4. Novotny, what's the net radical? -3. You have a 1 minus a 4, that's -3. Parker, is that real or imaginary? Imaginary. It's imaginary. All you gotta do is say it. You got -1/2 plus or minus the imaginary root of 3/2. That took some time. We spent all that time to find all those zeros. All that guessing was done for two things that aren't even what? Real. All that guessing is to find two things that aren't even real. Anyway, I'm done with that. Let's start here tomorrow. After you take a what? One credits. Again, if you hit your goal, you're not taking it tomorrow. By all means, go ahead and start on